Hello, hi friends. Today we will see how to create a parametric pattern in Rhino and Grasshopper. So first of all, I'll create a polyline. I'll snap to 0 and I'll draw my line, maybe the straight line around 50 meters. Yeah, and I'll do the copy of this line. Go to my front or right view and I'll move this line up the copied line. So I'll maximize the perspective viewport. Right now I have two lines. I'll open my Grasshopper. Before that, what I'll do, I'll rebuild my this curve. So rebuild will give you the points. So I'll do it one by one. So I'll rebuild this bottom curve first. So it will be generating a number of points based on the count which we give here. If we reduce it, will reduce it. So I'll keep it as it is and I'll just give OK. Similarly, I'll rebuild this curve also. And I will open my Grasshopper. Let it open. So opening the Grasshopper, I will take a curve and select multiple curve. Set multiple curves. Once you set multiple curves, it will show you the Rhino space, and you need to select the curve. So first I will select this curve, and next I will be selecting this curve, and I will click enter. So the curves are selected, the warning sign disappeared, and we have loaded the data into this curve. Next I will be using the component loft to create a surface between these two curves. So I will connect this curve here. Once after the connecting, it will show you that it has created the surface. So what I will do right now is I will click my polyline. We have these points. I will adjust my points so that I can create a kind of undulated pattern, something like that. Yeah, and like this. So I do not want it to be straight surface. I want the facade to be kind of undulated or something wavy. Okay, so it's created. I'll keep the polygon high quality so that it doesn't look very broken. Once after that, what I should do is I should be deconstructing this surface. So what component we have to use is we have to use the component called deconstruct brep. So what is the function of this component is it will deconstruct this surface into, like, it will show you how many faces it has, how many edges it has, and how many vertices it has. So in our case we have one face, 4 edges, and 4 vertices that you can see while you are hovering over the cursor on top of this component. Next I will be taking the isotrim component. So isotrim component I'll be using to divide my geometry into segments. For that we need to use a component called isotrim. So isotrim will take any of the surface and it will give you the segments out of it. So what it's asking for is the input is the base surface. So we cannot directly connect the face to this isotrim. So what we have to do is we need to use a component called surface. So I'll take this face and connect it to surface, and it will give me the surface of it. Yeah, and I will be taking this surface as a input and connect it to my subsurface isotrim. and it's asking for the domain of subsets, so how we have to divide it. So to get that, what component we need to use is we need to use the component called divide domain. So this is the one. So this one is showing this the logo is like one surface is divided into so many segments. So this is the component which we need to use. I'll click this and I need to input my surface into this base domain. So this is my surface and inputting this one, and I will be connecting the surface to the segments to the this one, the domain of subsets. So by default, whatever the values are for this u and v, it will divide based on that. We have 10 and 10, but we can increase these segments as per our wish. So I'll add 50 by slider, and I'll take a copy of it, and I will make one as 80. Yeah, 50 and 80. So it divides the surface into 50 segment, 50 by 80 segments. So now what I will do is I will further divide this each of these bit of surfaces. Now it is like a single surface, and it's divided the segments into 50 and 80 numbers. What I will do now is I will deconstruct this isotree. So reconstruct B-rep. Yeah, so it will be like each of the surfaces are become individual right now once after deconstructing the B-rep. So out of it, I will be taking each of these items, like each of these points, as my input. For that, I will be using the component called list item, which is mainly to select my points individually. So I will connect my vertices to the list. So it will by default, whatever that index value, it is 0, right? That will show that point. If your index value is 1, it will select that the point 1. See, this is selecting this one. So I'll give this 0. I'll take a copy of this one more time, and one more time, because we have 4 points on the one surface, right? So 4 times I'll be taking a copy, and I will add the index for each of these component. So each of these list is created to output my in points. Yeah, with this in list, I will be creating my 4-point surfaces. So because right now we have this deconstructed, but we do not have a surface, so I'll be using these 4 points to create my new surface. So I'll connect all these listed items into 4 points, so that it will give me the surface for each of these segments from out of from these segments. Now once after this, what I have to do is I need to evaluate my surface to find out the point, fix my point on that surface. So I'll be using the component called evaluate surface, and I will connect my base surface. This is my base surface to this one. Yeah, and I will be using the component called surface closest point. We have a component called surface closest point to find the point on the fix the point on the surface. So So I'll be giving the same surface as my input and connecting this UV to this UV parameter. So we're clear until here, and what we need to give is we need to give the sample point location. So how we can give the sample point? We need to find the centroid of each of the surface. So for that we can use the component area. So area will show you the centroid for each of the surface. So this one is giving the centroid of each of the surface, and I will take this centroid as an input and connect it to my sample point here in the closest surface point. So with reference to that, so we are getting the surface evaluated. Then what I'll do, I will just select this component and just hide it for time being. Okay, so I'm going to create a geometry on this surface for each of the surface. So I will be taking a circle component. So it's asking for the input, create a circle defined by center. So normal and radius. So in our case, the center is the centroid of this surface. And the normal is this is that we have evaluated the surface, right? This normal will connect it to the circle so that it will orient to that face. Yeah, you can see this difference. Before connecting it is in the up down direction. Once after you connected the normal to this circle normal, it is taking that face of that the evaluated surface. So that's the reason we are using this evaluation, right? And this circle I will be scaling it down with various radius for each of the surfaces, the divided surfaces. So for that we can use the component scale. So you can type scale and connect this geometry. And the center reference you can give the same centroid reference. So once you have created this scale, it will take the default of the factor 0.5 and scale down the original circle from that. Yeah. So now we have scaled the circle, but we do not want the regular scale down of the circle. What we need is the variation in the geometry for each of the surfaces. So what we have to do is we can create a component called curvature. This is mainly to create the variation in the factor of radius of each of the circle in each of the surfaces. So I will take my base surface and I will copy this surface closest point one more time. This curvature. Sorry, this is not the one. We need to create a component called surface curvature. We have this one, surface curvature. Take that and connect the base surface and surface closest point. You input it to this one UV. The remaining all input be the same, and you can give the multiplication factor for this on curvature. So I'll be using the component multiplication. So I'll connect this multiplication for the first value to A, and I'll add the value as a number slider for the variation in the factor as B, and I'll connect this result of multiplication in the factor. So meanwhile you can just hide all this component where you can see the results very so if you when you adjust this one, I think with respect to that value it will so you can hide all this. Instead of 1, I'll just give 0.5. See, it is creating the variation of radius for each of the points with respect to the surface closest point and the multiplication factor which we have created. Once after that, you can add the boundary. And connect the geometry. So this will create a boundary for the geometry, and you can preview the geometry. Also, you can add a color swatch. Create a color out of it. So I'll hide these points, everything. Yeah. I'll create a 0.1 less than 2. So what it does is it will give the value from 0.1 to 2 instead of 1. So I will connect this and increase the size a little bit. So this creates the pattern now. Perforated pattern in the surface, right? Can just bake this too and give OK. Yeah. Okay, so like this you can create a perforated pattern on any kind of surfaces. So this is the very basic technique of creating the varied size of geometry on the any kind of surfaces. Hope this video is helpful, and I will let you know how to do the boolean out of it and create other different geometry on the surface in different video. Please like my video if you do like it, and please subscribe to my channel for more similar videos in the coming days. Thank you.